Consider the hollow shell that's in the picture of the statement of the problem. And if we look at a potential mass element, then that mass element is going to be the density, since it's constant, times a element of volume. And the volume of the cylinder would be given by 2 pi RL. That would be the surface area of it times dr, which is the thickness. So we can say that this is 2 pi L rho r dr. And if we're going to find the mass, then we're going to have to do an integral. And the integral would go from the small radius, little r, to the big radius, big R, R1 to R2, I mean. So the moment of inertia, I, is going to be the integral of r squared dm. Remember, it was mr squared or md squared before, but because we have the mass element, we will put that second here. It doesn't really matter. So this is from r1 to r2 of r squared times 2 pi L rho r dr, which is the same as the integral from r1 to r2 of 2 pi L rho r cubed dr. And notice that these terms 2 pi L rho are constant, so we can move those outside the integrand. I get from r1 to r2 r cubed dr, which is the same as, this becomes r to the 4th over 4, so we will get pi L rho over 2, and then r to the 4th evaluated between r1 and r2, which means that the moment of inertia is given by, pi, let me get the eraser here, pi L rho over 2 times r2 to the 4th minus r1 to the 4th. And if you notice, that is a difference of 2 squares, so we can rewrite this as pi L rho over 2 r2 squared minus r1 squared times r2 squared plus r1 squared. And since we know that V, the total volume of the cylinder, is pi L r2 squared minus r1 squared, then we can say the mass, the total mass, is capital M, which is rho V, which is rho pi L r2 squared minus r1 squared. And so if we take rho L pi and so if we take pi L rho and this term, that will be our M, So we have, now we have I equals everything in red I'm going to write as m, but first I have that 1/2 first in front, then m, then what's left is the r2 squared plus r1 squared, and we found an expression for the moment of inertia using integration.